Klipper is a word we hear a lot these days throughout the 3D printing community, and for good reason. Today some manufacturers are shipping out 3D printers with Klipper already installed. For those of us with older printers, we must undertake this firmware conversion ourselves. This typically involves a Raspberry Pi, on which we install the Klipper firmware and then transfer an image to the printer, allowing them to communicate with one another. Today, we're using the Pad 7 from BigTreeTech, which already has Klipper installed on it. We're going to couple it with the average Ender 3 clone 3D printer. Without further delay, let's get to it. Looking at the packaging, we see the Klipper logo stamped in the corner and a "Not only for Klipper pad" message on the front. One of the items we find inside is the instruction booklet, which contains some basic information, like what components are included, a QR code that points to the BigTreeTech GitHub, the pad's dimensions, and information on the interfaces it's equipped with. BigTreeTech also provides some stickers if you're into this kind of things. Moving on, one of the boxes contains a 12-volt power supply, which is able to output 2 amps and therefore 24 watts. The other box includes the rubber ducky from BigTreeTech, a bag of accessories which we will go over, and a bunch of socket adapters which should cover most of the regions. Lastly, we find the Pad 7 itself. The front is taken mostly by the 7-inch touchscreen. A light sensor is present on the top left corner of the pad, and some RGB status LEDs on the top right. Moving on to the back, we see the device is equipped with a DC plug for the 12-volt power supply, 2 USB connectors for connecting devices such as cameras or maybe multiple 3D printers, an Ethernet port as well as a CAN bus connection, and finally an SPI connection for connecting the supplied accelerometer. Hidden away on the back side, we also can observe 2 speakers that can help us reproduce sounds outside the spectrum of just beeps and tones. On the right side, another USB 2 connector is available, as well as a USB OTG port, or USB on the go. In the middle of the two, the SD card slot is located, and we can see that BigTreeTech provided a 32GB micro SD card, which actually holds the Klipper installation. On the left side of the pad, 2 volume buttons are present towards the top, and towards the bottom we finally see a 3.5mm headphone jack. On the top side, we can observe a lonesome power button. The small bag we saw earlier contains the following items: a thermal pad, which could be used if the CB1 is changed with a CM4, a DC power jack, which could be used to DIY the power connection to the pad instead of using the provided power supply, some spacers and screws if you wish to convert to the CM4 board, the SPI connector cable for the accelerometer, and the ADXL345 accelerometer itself. Finally, we are provided with a USB adapter for the SD card and micro SD cards so that we can transfer data from and to the pad if necessary. Let's dive deeper and see exactly what is under the skin of the Pad 7. Removing the small plastic cover at the bottom reveals a section with multiple toggle switches. CS Choose allows us to choose between the CB1 or CM4 modules depending on which ones we are using. Since we are using the CB1, we will leave it on that position. The mode section has 4 jumpers that deal with the boot states, SoC resets, and other functions. We will not deal with these, so we will leave them on the default positions. And finally, another toggle switch for the USB on the go interface, depending on whether we are using the CB1 or the CM4. The cover also has the labels for these switches shown for convenience. The CB1 does not have a fan cooling the main board, and BigTreeTech opted to use this big heatsink for cooling. Removing it reveals the CB1 board and a thermal pad. We can advance further and remove the board itself. First, the spacers have to be unscrewed, and then, very carefully, disconnect the Wi-Fi antenna from the board. Using some tweezers or a small flathead screwdriver, slowly lift the board from the 100-pin SMT connector on one side. The connector on the other side still needs to be disconnected, so I used 2 screwdrivers to slowly and gently lift this side of the board as well. There it is, the brains of the operation. The CB1 board has an all-winner 616 quad-core Cortex A53 CPU, running at 1.5 GHz. The board is also equipped with 1 GB of DDR3 memory. Not as powerful as a Raspberry Pi, but sufficient enough for 3D printing application. Okay, time to put everything back together and begin configuring the device. After plugging it in and turning it on, the pad goes through a boot up sequence. The first thing displayed is an error message related to a file. We will fix this in a few minutes, but first let's try and connect the pad to a Wi-Fi network. Select Settings from the main screen, followed by the network icon. Here we should see all the networks discovered by the device. Select the desired one by pressing the icon on the right and input the credentials. We are prompted by some messages, followed by a connected confirmation. At this point, I decide to perform a reboot of the device. Now, the pad is connected to the network, and we should be able to access it through a web browser or any computer or phone connected to the same network. You can find out the IP to connect to by using the Klipper pad as shown or through your router settings. Alternatively, instead of the IP address, the hostname btt-pad7.local can be typed in the browser to access the device. The interface we are presented with is called Mainsail, and it is a lightweight, responsive web interface for managing and monitoring 3D printer operations powered by Klipper. From here, we can control the printer and edit configuration files on the pad. On the left side, we have the main menu where we can access the configuration files as well. At this point, I would recommend updating all the software components installed on the pad. It can be done one at a time as shown, or all at once and can be initiated from Mainsail or the pad itself. While the software updates, let's go over some of the installed components briefly. Klipper is the firmware for 3D printing and is running on the pad. Mainsail is a responsive web interface for managing and monitoring 3D printer operations powered by Klipper. Moonraker is a back-end service facilitating communication between Klipper and web front-ends like Mainsail. Klipper Screen provides a local control interface for printers without the need for a separate device or web browser, just like this pad. Crown's Nest is a script that facilitates webcam functionality for Mainsail. Sonar is a watchdog for certain processes, and Timelapse provides the possibility for the user to create time lapses of their 3D prints. Now that the updates are complete, let's move on to the next steps. One of the first things that we have to do is provide the printer configuration file. Opening the printer.config file, we see that it only has 2 lines present. We need to find the configuration compatible with the printer we want to use. In my case, it is the Sulu T3. Most of the common printer configuration files can be found on the Klipper GitHub page, which I will link in the description. Here, I searched for the Sulu T3 config and I copied the contents to the printer config file on the Pad 7, keeping the included Mainsail config line. Just make sure to comment out, using a hashtag, the included generic BigTreeTech config line. I will not go into detail about the contents of the config file, as it is outside the scope of this video and can differ from printer to printer, but I encourage you to review it carefully and make sure everything matches your printer's specifications, and also consult the Klipper documentation as it will explain the role of all these parameters in the file. Now that you have all that configured, it's time to connect these two. However, the Pad 7 does not come with a USB cable. Hopefully, you have one of these from the original packaging of your 3D printer. Connect the USB Type-B connector to the printer and the Type-A to one of the USB slots of the Pad 7. Before Klipper can be installed on the printer, we will need to generate the file from the Pad 7 and transfer it to the printer. Using a program such as PuTTY, SSH into the pad using the IP address as shown. When prompted for username and password, enter BIQU for username and password. We will now have to change directory to Klipper and run the make menu config command. On the next screen, we are prompted to choose certain parameters that mainly depend on the 3D printer board you have. In my case, the printer.config file for the Sulu T3 contains all the instructions at the top of the file. So let's go over them.
First, we should enable the extra low-level configuration option. I have to select the microcontroller architecture. In my case, it is the STM option. The processor model falls to the default STM32F103 as per instructions. Instructions also say we should change the bootloader offset to 28 KB. Communication interface should remain USB. Next, we get to disable the SWD as startup option. And finally, input the specified value for the GPIO pins. Once we are finished, press Q to exit the menu and save the config file. At this stage, we use the make command, which will compile a firmware file locally on the pad. As you can see, following the command, a new Klipper.bin file is present in the out folder. Now, we must find a way to get this file from the pad to the 3D printer. You will need to have an extra microSD card to accomplish this. Open a command prompt on a Windows computer and enter the following command in the terminal. You will have to put the BIQU username here, the IP of the pad here, and your own Windows directory path here. This should copy the Klipper.bin file from the pad 7 to your computer. Alternatively, you can use an FTP client such as WinSCP to transfer the file as well. At this point, we insert a different microSD card, so not the one that came with the pad, into the included adapter and connect it to the computer. We transfer the Klipper.bin file to the SD card and rename the file firmware.bin. Eject the drive from the computer and insert the microSD card into the printer with it turned off. Turning on the printer will flash the new firmware to the 3D printer board. This process should take a few seconds, but just leave it alone for a minute just to make sure the firmware is flashed properly. Restart the printer. The pad 7 is still not communicating with the printer, and there is one more step we need to take. Run the following command on the pad 7 terminal so that we can find out the USB serial address. Finally, we copy the results to the printer.config file as shown. We finally have full connectivity to the printer. At this stage, you can start testing. We can see that the homing and axis movement work without issues. The printer can even be controlled from the control unit on the printer. Go through the pad settings and make sure everything is to your liking. For instance, you can change the screen turn-off time for when the pad is not being used. I also suggest to run the Z-offset calibration procedure from the pad and optionally the bed leveling option, which helps you level the corners of the bed using the hot end nozzle. There are other things you should probably address, such as E-steps calibration, pressure advance, PID tuning for the hot end and bed, but these are outside the scope of this video. What we will look at further is how to configure the accelerometer. First things first. We will have to add the following lines in the printer.config. These can also be found in the user manual. Additionally, we have to specify where the resonance testing will happen by adding a configuration parameter similar to what is shown here. Next, connect the accelerometer with the provided cable to the pad. Restart the firmware and check with the following command if the accelerometer is providing any readings. Everything checks out, so we are ready to move on to the next steps. We will have to test each of the X and Y axis one at a time. Find a way to attach the accelerometer to the X-axis carriage and make sure the labeling corresponds to the direction you are testing. Run the following command for the X-axis testing in the Klipper console and wait for the testing to finish. Save config to use the suggested values after testing. Repeat the same procedure for the Y-axis, just make sure to change the command for the Y-axis in the console. Input shaping is complete and we can see the new parameters at the bottom of the printer.config file. Now, before we print something, let's attach a USB webcam to the pad and see if it works. Looking in the webcam section of the settings menu, we can observe that the camera is automatically detected. Nice! Additional steps that should be taken is to provide a start print and end print macro in the print.config file and link these with the slicer software you are using. I will provide resources in the description to help you have that set up. I went ahead and printed a Benchy and used the built-in time-lapse functionality, and here are the results. So, there you go, the Pad 7 from BigTreeTech. I think it's a good option for a Klipper conversion on a 3D printer, especially today as the Raspberry Pi is hard to source. You get a Raspberry Pi functionality coupled with a screen and multiple configuration options, all packaged in a reasonably priced solution. You also get an accelerometer for input shaping. Make sure to subscribe and stay tuned, as we may try different things with the Pad 7. See you on the next project!